Have you ever looked up at the night sky, seen a single point of light, and just wondered, what is really up there? Well, tonight, we're going to journey to one of those points. But you know, this isn't just a star. It's a vast, ancient city of stars, a stellar metropolis with a story written in pulses of light. And it's hiding secrets that astronomers are only just now beginning to decode. So let's dive in.
Our destination is a place called Messier 5. It is so ridiculously far away that the light we're seeing from it tonight actually started its journey 24,000 years ago. Just think about that. And inside this celestial city, you've got hundreds of thousands of suns all packed together in this glittering ball. And deep inside its core, something is sending out signals, like a hidden rhythmic heartbeat.
So what exactly is Messier 5? Well, astronomically speaking, it's a globular cluster. You can find it in the constellation Serpens Caput, and it's one of the oldest clusters in our entire Milky Way galaxy. The best way to think of it is like a fossil from the early universe, this dense swarm of ancient stars that have been orbiting our galaxy for billions and billions of years. Okay, so to understand M5's secrets, we first have to kind of listen to its rhythm. For decades, astronomers have been studying the overall pulse of these star cities, and believe me, that pulse tells a fascinating story. Now, this pulse, it comes from a really special type of star called an RR Lyrae variable. These are old, unstable stars that literally swell and shrink, which causes them to brighten and dim in a really predictable rhythm. You can almost think of them as the collective cosmic heartbeat of the entire cluster.
Now here's where it gets really interesting. Not all of these star cities have the same heartbeat. Way back in the 1930s, astronomers found something they call the Oosterhoff dichotomy. And they realized that globular clusters fall into two totally distinct families based on these pulses. You've got group I clusters with a faster, sort of standard heartbeat, and then you have group II clusters with a slightly slower, different rhythm. It's been a fundamental puzzle in astronomy for a long time.
So where does our star city, Messier 5, fit in? Well, it is a textbook example of a group I cluster. Its stellar heart beats with that faster, standard rhythm, and this was actually one of the first major clues to its personality. And you know, this isn't just a theory, you can actually see it in the data. When astronomers chart the periods of M5's variable stars, they see this very specific pattern, this clear signature with distinct groups of pulsing stars. This whole distribution is basically the fingerprint that confirms, yep, M5 is a classic group I cluster. But that classic heartbeat, that's really just the beginning of the story. If we zoom in, way past the thousands of gently pulsing stars, and we listen with much more powerful tools, we find something far more extreme, far faster, and honestly, a little bit stranger. So, we're going to go deeper now. We're no longer listening to the gentle pulse of living stars. We're tuning into the frantic, high-speed signals coming from the ghosts they leave behind. We're talking about millisecond pulsars. Now, these things are the crushed, super dense corpses of massive stars. Some people even call them zombie stars. They're so dense that a single teaspoon of this stuff would weigh billions of tons. And they spin at these unbelievable speeds, sweeping beams of radio waves through space just like a cosmic lighthouse. And using massive radio telescopes, astronomers have peered right into the crowded core of Messier 5 and found these zombie stars. So far, they've timed 7 of them with incredible precision. And what's really cool is that some of them aren't even alone. 2 of them, for instance, form a binary system. It's known as PSR J1518 plus 0204, and they're locked in this constant gravitational dance. Just finding these things is an incredible feat of engineering and science. I mean, they are fantastically faint and mind-bogglingly fast. It takes some of the largest telescopes on Earth to even detect their whisper-faint signals. The hunt really started with the legendary Arecibo Observatory way back in 1989. And more recently, the colossal 500-meter aperture spherical telescope, also known as FAST, has taken up the mission, giving us the most precise measurements of these cosmic clocks ever recorded. So how do they even do it? Well, it kind of breaks down into 4 steps. First, you just observe. You point that massive telescope at the cluster for hours and hours. Then you have to filter out all the cosmic noise to find that one repeating signal. Next, you time the arrival of every single pulse down to the microsecond. And finally, you use all that timing data to build a complete model of the pulsar's spin and, if it has one, its orbit around a companion star. And the results from that process, they're just staggering. Take this number, for example, 402. That isn't just some random number. That's the number of times one of the pulsars in M5, named M5C, rotates on its axis, every single second. We're talking about an object more massive than our sun, crushed into a ball the size of a city, spinning faster than a kitchen blender. It's just wild.
So the big question is, how does something so extreme even come to exist? Well, the answer isn't just in the star itself, but in the violent life of the entire cluster.
This quote from the research really nails it. You see, Messier 5 doesn't just circle the Milky Way in a nice, peaceful loop. No, it has a highly eccentric or stretched out orbit that sends it plunging dangerously close to the chaotic center of our galaxy.
Just imagine this chaotic dance, right? Every time M5 dives towards the galactic core, the galaxy's immense gravity grabs hold of it. This creates these powerful tidal forces that literally rip and strip stars from its outer layers. Now, while this is slowly tearing the cluster apart, it also has this crucial side effect. It keeps the core incredibly dense and dynamic.
And this is where it all comes together. That chaotic, crowded core is the perfect stellar factory. It's a cosmic mosh pit where stars are constantly interacting, swapping partners, and spiraling into one another. And it's in this chaos that you can form the exotic binary systems you need to spin up a dead star into a millisecond pulsar.
So Messier 5 isn't just some ancient relic. It's a dynamic, evolving city, constantly being shaped by this violent dance with our galaxy. Its classic heartbeat tells us the story of its old age, while the frantic spinning of its zombie stars reveals the secrets of its chaotic life. And as it continues that dance, you just have to wonder, what other secrets are still waiting to be discovered deep in its core?